my YouTube video lecture series of the subject Basic Electrical Engineering. Myself Pankaj Shah, and you are studying subject Basic Electrical Engineering, and our topic is AC circuits. So now in this video you will see some analysis of series circuits. You have to analyze circuits, AC circuits, which are having more than one component. Means we will study an inductor. That was a pure inductor. That means inductor was not having any resistance. But in this video you need to understand what if inductor is having some resistance. So to represent that practical inductor, we are representing that internal resistance in series with that inductor. So today's topic is analysis of series RL circuit. So let's see the analysis of series RL circuit. In case of series RL circuit, first of all you have to draw the circuit diagram for this series RL circuit. So for that, what you have to do is you have to take the symbol of one resistor, you can see here, and with this resistor you have to draw one inductor in series with that resistor. So this combination is known as the RL series circuit. Now if we apply some source of energy to this combination, then this forms a circuit. And if we are applying the AC voltage to this circuit, then this is series RL AC circuit. So let's apply some source of energy to this series RL circuit. So the applied voltage is V. So the applied voltage V is distributed in these components. We have studied resistors connected in series. So in case of resistor connected in series, if we apply some voltage to that series combination, then current flowing through that series combination will be same. But the distribution of voltage will not be same. So the distribution of voltage will be different across each element connected in that path. So that means the applied voltage V will be distributed into different paths in this series RL circuit. So the voltage across resistor R will be VR and the voltage across inductor will be VN. So this is the series RL circuit. So we need to analyze this series RL circuit. An analysis of series RL circuit will contribute the equation of voltage, equation of current, phase angle between voltage and current, equation of power, vector diagram and waveform. So let's begin. So first of all, we need to take the equation of voltage V is equals to Vm sin omega t. And from that equation V is equals to Vm sin omega t, we need to define the equation for current I. So in this diagram, you can see that Vt is the instantaneous value of the voltage and we have taken voltage as a reference. So the equation of voltage is Vt is equals to Vm sin omega t. Now we need to find the equation of current. Also you can see this figure. In this figure, It is the instantaneous value of the current. So we need to find the equation of the instantaneous current. So for that we need to draw the phasor diagram, or you can say the vector diagram. So first we will draw the phasor or the vector diagram for individual component. So the voltage across the resistor is VR. And the current flowing through that resistor is the same current I. So let's first draw the vector diagram for the resistor. So in case of resistor, the voltage and current are in phase. There are no phase difference, no phase angle between voltage and current. So we can say that the phasor diagram for the resistor will be like in same line for the voltage and current. And in case of inductor, current lags behind the voltage by 90 degrees. So if we are taking current as a reference in this figure, so you can get this vector diagram for the inductor. So means if current is at a reference, then voltage will be leading from the current by 90 degree. And in case of resistor, it will be in the same phase because there are no phase difference between voltage and current in case of resistor. So now what we need to do is we need to combine these two equations. So how we can combine? So for that, let's consider a complete phasor diagram. So to draw a complete phasor diagram, what you have to do is you have to first draw the line of the current. So we have drawn one line of current here. On this line, you have to draw both the voltage. So first we will draw the voltage across the resistor, that is VR, and then we will draw a voltage across the inductor, that is VL. So basically, VR and VL will be drawn from this diagram. VR will be on the same phase as the current and VL will be leading from this current by 90 degree. Now again we have to use the vector addition technique, because the applied voltage is nothing but the phasor addition or the vector addition of this two voltage, that is VR and VL. So to add these two quantities, we are using a concept of vector addition. You have seen the concept of vector addition in previous videos. So if we are making one triangle, so the diagonal of that triangle will represent the vector addition of these two vectors. So this diagonal is the magnitude V, and this is nothing but the resultant voltage, or you can say the applied voltage. So we obtain the applied voltage and also we have the reference as the current. So now you can also measure the angle between the voltage and current. So this angle phi represents that voltage V is leading from the current by 5 degree, and also you can say that the current is lagging behind the voltage by 5 degree. Because we have taken voltage as a reference, so we can say that voltage is leading but current is lagging behind the voltage. So you can say that in this series RL circuit, current lags behind the voltage but by 5. So if we want to write the equation of the voltage and current, then we can write like this. So the equation is V is equals to Vm sin omega t, and current I is equals to Im sin omega t minus phi. We have written minus 5 here. In pure inductor, we have written minus 90, because in case of pure inductor, current lags behind the voltage by exactly 90 degree. But you have seen that in case of this series RL circuit, current is lagging behind the voltage by 5 degree. So our equations are V is equals to Vm sin omega t is our reference quantity, and I is equals to Im sin omega t minus phi is our current quantity. So the phase angle between voltage and current is 5 degree, and where Im is nothing but the maximum current flowing through this series circuit, and its equation is Im by Z, where Z is known as the impedance of this circuit. So this was the vector diagram of series RL circuit. Now let's see the waveform of series RL circuit. So in waveform, what you have to do is you have to first draw the x-axis and y-axis. You can see in this diagram we have drawn one x-axis and y-axis. On x-axis we will always take the angle theta, or you can say omega, and on this y-axis we will always take the quantity of which we want to draw the waveform. So we have taken voltage and current on this y-axis, and we have taken theta on this x-axis. So you have to draw first waveform of your reference quantity, and our reference quantity is the voltage, because we have applied voltage first to that circuit, and due to that voltage current was flowing in that circuit. So if you want to draw the voltage waveform, then the equation of voltage is Vm sin omega t, and Vm sin omega t, that means the waveform of voltage will start from 0 and completes its full cycle at 2 pi. So this is the very basic sinusoidal waveform, which is from 0 to 2 pi. Now we have to draw the waveform of current, but we know that current is lagging behind the voltage by 5 degree. So that means current will not start from the 0 and will not complete at 2 pi, but current will start after 5 degree of the voltage has been started. So voltage waveform is started at 0 degree, but current waveform is started 5 degree after the 0 degree. So there is a phase difference between voltage and current of 5 degree, and current will complete its waveform after the voltage has been completed by 5 degree. So you can say that the waveform of current is totally lagging behind the voltage by 5. So this is nothing but the waveform of voltage and current. Previously we have seen this waveform, but we have drawn the waveform of current by 90 degree in pure inductor. But in case of this, we have to draw the waveform of current by 5 degree. So this was all about the waveform. Now, the next part of the analysis is the main part. And the main part of the analysis is the power consumed by this series RL circuit. So let's understand first what is the definition of the instantaneous power. So instantaneous power is nothing but the power consumed by this circuit at any instant of time. So basically instantaneous power P is equals to instantaneous voltage V into instantaneous current I. So let's put, we have the equation of instantaneous voltage, we have the equation of instantaneous current. So let's put the equation of instantaneous voltage and instantaneous current in this equation. So the equation of instantaneous voltage is Vm sin omega t and equation of instantaneous current is Im sin omega t minus phi. So Vm and Im can be taken out because both are constant. So it will be sin omega t into sin omega t minus phi. Now let's multiply and divide this equation by 2. So it will be 2 Vm Im sin omega t minus phi divided by 2. So this 2 will be given to that 2 sin term. So that means Vm Im by 2 will be taken outside. So it will be Vm Im by 2 and in bracket it will be 2 SS. That is 2 sin omega t into sin omega t minus phi. So 2 SS will give you the formula of C minus C, and in first C that will be cos, and in that cosine term there will be subtraction of angles. So you can see that omega t minus omega t minus phi. So in bracket it will be omega t minus phi. If we open that bracket, then it will be omega t minus omega t plus phi. So omega t will be cancelled out, and in this first cos term it will be only phi. So it will be Vm Im by 2 in bracket cos phi minus again C minus C. So in the next cosine term it will be the addition of the angles, and you can see the addition of angle is nothing but omega t plus omega t minus phi. So it will be 2 omega t minus phi. So this is the instantaneous power. Now let's see the average power consumed by this series RL circuit. So to find the average power, we have to do the integration, because we want to find the average power consumed by this series RL circuit in one complete cycle. So we have to integrate the instantaneous power in the one complete cycle, and we know that one complete cycle is between 0 to 2 pi. So we have to integrate the equation obtained previously in 0 to 2 pi. So the equation will be integration 0 to 2 pi P instantaneous with respect to d omega t, or you can say theta. So the equation of P instantaneous is nothing but Vm Im by 2 in bracket it will be cos omega t minus cos 2 omega t minus phi. So here the constant terms are Vm Im by 2 upon 2 pi. So in this equation there is a denominator 2 pi, because we are finding the average. So we must have to put 2 pi in the denominator. So now in this integration Vm Im by 2 upon 2 pi is the constant term. So from this integration term, let's take this Vm Im by 2 outside this integration. So in integration it will be 0 to 2 pi 1 by 2. In bracket you have to integrate cos phi with respect to omega t and minus cos 2 omega t minus phi with respect to omega t. This 1 by 2 is again constant. So we can take this 1 by 2 outside this integration. So it will be Vm Im by 4 pi. So in integration it will be 0 to 2 pi integration of cos phi with respect to d omega t minus integration 0 to 2 pi cos 2 omega t minus phi with respect to d omega t. So we know that the integration of cos phi with respect to omega t, cos phi is constant, so there will be 1, and the integration of 1 with respect to omega t, it will be omega t. We have to put the limit 0 to 2 pi in that bracket. Now the integration of cos 2 omega t minus phi with respect to omega t will be sin 2 omega t minus phi divided by 2, because there is a 2 omega t, so divided by 2 will be according to the chain. So in the first bracket, instead of omega t, we will first put the limit 2 pi. So it will be 2 pi minus 0. So there will be only the single term 2 pi. So it will be 2 pi cos phi. In the next term, we have to put the limit 2 pi and 0 instead of omega t in this equation sine in bracket 2 omega t minus phi. So if we first put 2 pi instead of omega t, then it will be 2 into 2 pi minus phi. So it will be sine 4 pi minus phi in this equation. And if we put 0 in this equation, then it will be sine 0 minus phi. So you can see this last equation, we obtain Vm Im by 4 pi, in bracket it will be 2 pi cos phi minus Vm Im by 8 pi, and in bracket it will be sine 4 pi minus phi minus sine minus phi. So now look at this first equation. So the solution of this equation will be given as Vm Im by 2. Because 4 pi and 2 pi will be cancelled out, so only 2 will be there, and in bracket it will be cos phi. There will be negative sign, that is minus, it will be Vm Im by 8 pi, and in bracket sine 4 pi minus phi is nothing but the minus sine phi. And if we take negative sign of the second term outside, then it will be plus sine phi. So basically we can say that minus sine phi plus sine phi will cancel out each other. So it will be Vm Im by 2 into cos phi minus 0. So that means we only have one single term as Vm Im by 2 into cos phi. If we separate this two to understand the RMS value, then it will be Vm by root 2 into Im by root 2 into cos phi. And Vm by root 2 into Im by root 2 is nothing but the Vrms and Irms. So we obtain the equation of power in series RL circuit as Vi cos phi. In case of pure resistive circuit, the angle between voltage and current was 0. So if you put phi is equals to 0 in this equation, then you get the average power as P is equals to Vm. In case of pure inductive circuit, angle was 90 degree. So if you put 90 degree in this equation, then cos 90 is 0. So that's why average power was 0 in case of pure inductive circuit. Same for the pure capacitive circuit. But here in case of RL circuit, the angle is 5 degree. So that means we can define the average power as the average power consumed by the pure inductive circuit is nothing but the P is equals to Vi cos phi, where phi is the angle between voltage and current. So in this video, you have seen the analysis of series RL circuit. Thanks for watching this video. Stay tuned. In next video, we will analyze series RC circuit.